This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day wherever you're listening from, and welcome to episode 461 of IAQ Radio. It's Friday, May 26, 2017. This week we're going to flash back to a show we did with Richard Corsi, Dr. Corsi of the University of Texas at Austin. The original air date on this one was 9/26/14, and we talked about challenges and opportunities for the indoor sciences community. I want to wish everyone a happy Memorial Day weekend, and with no further ado, let's get into our show with Dr. Richard Corsi.
IAQ Radio marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Legends Environmental Insurance, the experts in insurance for environmental consultants and contractors for over 20 years at legends-enviro.com. That's legends-enviro.com.
Today's show, we're going to talk to Mr. Richard Corsi. Dr. Corsi is the Chair and ECH Bantel Professor for Professional Practice, Civil Architectural, and Environmental Engineering at the University of Texas at Austin. He has a Ph.D. in Civil Engineering from the University of California at Davis. Got that in 1989. He joined the faculty of the University of Texas at Austin in 1994. And he conducts research on indoor air quality, including the sources and control of indoor air pollution and human exposure to indoor toxins. He has also studied how architectural materials can remove chemicals from building air, offering protection for occupants following terrorist attacks. Dr. Corsi, do we have you on the line?
You do. Hi, Joe. How are you?
Great. Thanks for joining us. I know you had a busy day and you squeezed us in between a couple of meetings.
Yes, I did. This is a joy, though.
Well, good, because in the intro, I talked a little bit about what we had discussed with respect to having some of your PhD candidates, and maybe, I don't know if they're all just candidates or maybe they're PhDs as well. Join us on some future shows to discuss some of their research.
And that'd be great. And we've got some wonderful students doing great things, and some of our past students are now doing great things, and that's what it's all about for me.
Well, and I'd love to get some past people as well. How many? I'm just kind of curious. How big of a department is it that you're with the professional practice, civil, architectural, and environmental engineering group there, and I guess your focus is indoor air quality issues and indoor sciences. How many people in that group?
So the whole department has 54 professors and 1,200 students, so a very large department. And the indoor air quality group, or we call it building energy and environments, is actually a very small group within that larger department. We have currently 4 professors that are doing research on indoor air quality, which actually is a pretty large group for indoor air quality at any university in the world, but 4 out of 54 professors. And we have at any given time now probably anywhere from 20 to 25 graduate students, master's students and Ph.D. students working with us. So, it's a relatively small group in terms of academic groups go. It's a relatively large program in terms of the indoor air quality field.
Yeah, I can't think of any other in the indoor air quality field that would have those kind of numbers. I mean, who else has a good program for indoor air quality?
Well, traditionally, a lot of the research on indoor air quality, at least in the United States, has been in schools of public health. It's been more health-related, industrial hygiene-related. There hasn't been much in the sort of engineering domain. And so, Harvard School of Public Health has always done some good work on indoor air quality. UC Berkeley does work on indoor air quality, but they tend to have researchers that kind of spread across several departments on campus and not a nucleus in one area. Internationally, there are universities that are doing a lot more research than universities in the United States are now. Tsinghua University in Beijing, China, has a really strong indoor air quality group. National University of Singapore has a strong group. There are other universities in Korea and Japan that have strong programs, Taiwan as well. So I would say that a lot of the activity in our field now, at least from a research standpoint, is in the Pacific Rim. A lot more research money and just a lot more interest in the subject.
I'm glad you bring up the worldwide interest, because I know you were at Indoor Air 2014. I guess that was in Hong Kong, and you did a presentation called Challenges and Opportunities for Indoor Air Science for the Indoor Air Sciences Community. And actually, this was the closing plenary session. And I'm curious, before we get into the specifics of that particular presentation, what were your thoughts in general about Indoor Air 2014? What kind of hit you that you wanted to make sure that our listeners are aware of?
I think it was a really good meeting. I think my impressions are, in terms of big picture, I think that the research being done in the Pacific Rim is really improving in its quality substantially. There were a lot of really exceptional presentations by researchers in China and elsewhere. So that's number one. And of course, because of the location of the conference was dominated by researchers in that area. I think the second thing is that there is so much going on right now that advances our understanding of microbiology in the indoor environment. So there was a wonderful thread of sessions and workshops at this conference that were actually organized by somebody who's been a speaker on your show before, I think Hal Levin.
Yes.
And they were organized for this conference, and there were activities every single day looking at genomic analysis and all these DNA-based measurements and trying to understand better about indoor microbiology and ecology and the fact that there are good bacteria in buildings and bad bacteria, and we shouldn't try to eradicate everything in buildings because some of the good bacteria in buildings actually have an effect in staving off mold in buildings, and a lot of great research on linking with these new molecular tools, improved understanding of microbiology and asthma in buildings. So I would say that really stood out to me as being the topic that I think we're seeing great advances in. I think that relative to Indoor Air 2011, which was in Austin, there was much less of a focus on practice, and that's one area where I would have liked to have seen more interaction between the research and community and practitioners. And I think in part that's because of where it was located. I think that indoor air quality practice is a much more robust sector of the field in the United States than it is in the Pacific Rim, at least at this point. And so I think that was one thing that was lacking from the conference. But otherwise, I thought the conference was really exceptional.
Do you know, I get the same impression that, in other parts of the world, there just aren't a lot of practitioners out doing indoor air quality consulting, I guess we could call it. I guess that's because they're just kind of catching up on the curve of things with respect to the issues that can be caused by bad indoor air quality. Is that...
Yeah, I think it's partly that. I think also some of the governments in other countries are actually a little more aggressive in dealing with indoor air quality problems than we are here. And here, if you're a homeowner and you have a problem, there's no government agency that's going to help you in the United States. Right, and so the public and private building owners in the United States are really dependent upon consultants, people with expertise in indoor air quality, to come and help them when they have problems, because there isn't sort of a structure outside of consultants to help them with problems. And some other countries do. They're actually, I think, a little bit more progressive, if you want to, in that sense, than the United States. But I think in the United States, private building owners are on their own when it comes to indoor air quality, and they usually don't have knowledge to solve their own problems, so they have to bring people in to help them solve their problems. And I see less of that in other countries than I see in the United States.
Well, that kind of leads into a little discussion of your presentation on the challenges and opportunities for indoor air science, for the indoor air science community. We all know that indoor air quality can affect occupants. How does indoor air quality affect those building owners that you were just mentioning?
Yeah, that's a great question. I guess there'd be maybe a twofold answer to that. The first is if the building owner also has their primary business in the building, then they should worry about the productivity of their workers and whether their workers get sick or not and don't come to work or leave early because they have headaches and that type of thing. So if the building owner is also running the business in that building, then it can affect their business if the indoor air quality is poor, the indoor environmental quality is poor, just in terms of worker productivity. I think if the building owner is leasing the space to somebody else and that space has, develops poor indoor air quality problems, and I've been involved with cases like that in Austin, the building ends up developing a stigma. People find out when the building you own has had problems, and that makes it harder to get good people to come in and lease the space. So I would say in the first case it's productivity if you own the building and the businesses in the building or business, and then the second case it's more of a stigma issue.
And I guess depending on what type of indoor air quality issue you have, you'd also see the building itself maybe deteriorating more quickly and requiring more upkeep and maintenance, etc.
Absolutely. So we know that there's microbiology that goes on in buildings and chemistry that goes on in buildings that can degrade everything from electric wiring to rot in wooden structures and even degradation of rubber materials. I've been involved with a case where toilets were decomposing, if you will, the wax seal on them because of oxidation of them, because of very high ozone levels in the building. So, you have to watch out for those types of things. And if there are historical artifacts or works of art or something like that in the building, those can be degraded by poor indoor air quality. We have a facility here at the University of Texas called the Harry Ransom Center that takes on lots of historical artifacts, Gutenberg Bibles, and we have the oldest photograph on Earth and that type of thing. And I know that the staff there goes out of their way to protect those kinds of artifacts from pollution that enters the building. So, yeah.
What is the oldest photograph on Earth of?
It's of a farmhouse with a tree next to it, and they put it out on display occasionally, and it's in a little dark room, and it's under an argon shield, and they have special lights they shine on it so it doesn't degrade, and you have to walk in and look at it from several different angles before you can actually see it. It's on a metal plate. But it's neat to see it when it comes out. It comes out every so often. And I've seen it now about 10 times. It's just such a wonderful thing to see.
Interesting.
I think it was taken somewhere in Europe. I can't remember where.
Well, yeah, I remember reading a little bit about early photography and how long it took for one photo to be taken. Essentially, it would take,
right.
And so that's why I wondered, because if it was a building that wasn't moving, you were a little better off than trying to take a photo of a picture back or the person.
Yeah, there were no people in the photograph.
Interesting. All right, and then let's talk before we get into some of the dynamics and the complexities of IAQ research. I want to ask, how does it impact, or how much impact do buildings have on our natural environment?
Yeah, this is a subject I lecture to my students a lot about, because we tend to isolate buildings and somehow treat them as if they're not connected to the rest of the world around them. But certainly we know that buildings consume about roughly 40% of all the energy in our country. And so, a lot of fossil fuel burning goes into producing the energy that's needed for buildings. And that fossil fuel burning ends up releasing a lot of greenhouse gases, and aside from that, just regular old-fashioned air pollution, outdoor air pollution. So one would be the energy consumed by buildings and its effect on the outdoor atmosphere. The other is that we now see, especially in the Antarctic and the Arctic, polar bears and penguins, there's been lots of studies showing the accumulation of flame retardants, and even negative effects of flame retardants and other persistent organic pollutants in those animals. I mean, far away from any buildings, right? Mm-hmm. And by and large, a lot of the things that we see accumulating in animals and really in the fat of animals in really remote regions that can actually affect. There's been some studies on the bone density of polar bears. going downhill because of exposure to flame retardants and other persistent organic pollutants. And we have to remember that those chemicals, whether they're coming from buildings or they're coming from the manufacturing facility and are intended for buildings, the point is that these are chemicals that are used in buildings. And so when we want to produce these chemicals to be used in buildings, or we use the chemicals in buildings, they do get out into the natural environment. They do migrate as far away from buildings as we can find them on the globe, and they are having an effect on ecosystems. So the building environment does affect the outdoor environment for sure.
Yeah, I can imagine. I mean, you're in Texas, and Austin's pretty densely populated. But if you look over to Houston, for instance, you've got all these buildings just packed into an area there that it's got to have an effect on the on the natural environment around it. I mean.
Yeah, certainly on the microenvironments as well, in terms of shading and lack of sunlight and those types of things, yes.
Yeah, and then water runoff and things like that have changed dramatically. We've changed all those things with our activities.
Right. The built environment and the natural environment around it are so interconnected in both directions. And oftentimes, people specialize in one thing and they don't see the other thing because they think very narrowly. And there's one great example. We have, great researchers studying natural water quality in rivers and streams. And then there are researchers that study the built environment and how to make the built environment a better place for people to live. And the connections between those two things don't happen because those two groups of people don't talk to one another.
Well, that kind of, again, leads me into the next question. You say IAQ research is dynamic, and I want you to explain for our listeners what you mean by that.
So it's dynamic on different scales, and if you think more long-term, one of the things I did in preparing for my closing plenary speech in Hong Kong was to look back at the Indoor Air 2002 meeting and the Indoor Air 1999 meeting. 99 was in Edinburgh, Scotland. 2002 was in Monterey, California. And I just went through all of the papers for those conferences, sort of skimmed through them, and compared them with the subjects and the papers that were being presented in Hong Kong. And that's not a long time. We're talking 12 years. That's all it was, back to Monterey, something on that order. And in that time, if you look back to Monterey, there were no papers presented in Monterey on the effects of climate change on indoor air quality, whereas in Hong Kong, there was a whole bunch of papers on that subject. In Monterey, there were no papers essentially on the use of DNA-based testing because of these new technologies that have emerged to understand microbiology in buildings. Here we are in Hong Kong 12 years later, and there's a thread of 100 papers on that subject, right? Nobody was talking about flame retardants and endocrine-disrupting chemicals and plasticizers in Edinburgh, and very few people were in Monterey. Now we've got 50 or 60 research teams that are studying that and presenting their work at indoor air conferences. So even in the scale of a decade, the sort of major topics, at least in the research field, have changed dramatically. So that would be sort of on a decade scale. Of course, and I know that buildings are also extremely dynamic, right? People in the buildings drive a lot of what happens in buildings, and those people come and go. They come in the daytime, they leave at the nighttime, or they come in the nighttime and they leave in the daytime. That external meteorology changes, which changes air exchange rates at buildings, due to changes in wind pressure around the external facade of the building and that type of thing. So even on the scale of minutes, indoor air quality in the indoor environment can change because of just natural changes and natural activities in buildings. So we have scales that are on the order of minutes to scales of decades, and we can see the changes in the dynamic nature of buildings on those very frequent and those very less frequent scales.
And then,
I hope that makes sense.
Absolutely, but you also mentioned in the paper here that the IAQ research is also very complex, and I think you started to discuss that complexity when you're discussing how dynamic it is, but maybe you could add a little bit on the complexity of indoor air quality research at this point.
Two great examples of the complexity, I think, is that if you go back in the literature all the way to the 19th century, the mid 1800s, there were physicians in the United States and Europe then who were writing books and papers and treatises on symptoms they were seeing in their patients that today absolutely define what we call, sick building syndrome, the symptoms of sick building syndrome. That was 160 plus years ago that physicians were writing about this, and we still don't fully understand SBS. We still don't fully understand all the reasons and causes of SBS. So that to me in itself is a good marker for how complicated, especially health symptoms are in buildings. The other one is building dampness. I mean, there's overwhelming evidence that people have respiratory problems and other problems in buildings that are damp buildings. I mean, I think that's very conclusive now. But we still haven't been able to figure out why. I don't think it's the water vapor that's causing people to get sick. Something's happening due to the dampness, and whether it be microbiological or chemical, we don't know. But nobody's been able to find the agents or the combination of agents that actually are causing people to be sick in damp buildings. And this research thread has been going on for 2 decades now or more, and we still don't have an answer. And so I think those are 2 examples of how complicated building environments are with respect to bad things that happen in them that we still haven't been able to figure out. I think the other thing I would point out is that there are so many connections in buildings that, buildings are complex systems. They're systems of systems. They have anatomies just like human beings have anatomies. And we all know that if something bad happens in one of our organs, what's going on in that organ can sort of cascade to the rest of our body and have negative effects. The same thing's true in buildings. We have people who are experts in thermal comfort. For example, at the Indoor Air Conference in Hong Kong, there were maybe 150 papers on thermal comfort. I mean, it's always been a huge field. But the people that study thermal comfort have no clue what the effects of changing environmental conditions for thermal comfort have on indoor microbiology or indoor chemistry. If you increase temperature or you relax, sort of where we want to be in terms of humidity ranges, what effect does that have on microbiology or chemistry? We don't know because the people that are chemists and microbiologists don't talk to the thermal comfort people, and the thermal comfort people don't consider microbiology and chemistry. These are complex interactions that we need to do a better job of sort of connecting together in a more holistic anatomical system sense for buildings, I think.
Well, and you're a researcher, and you work with a lot of researchers. I would imagine that, this, and I'm stealing this from your presentation, though, but this really makes our field very much ripe for cross-disciplinary research and innovation. And are you seeing any of that?
It's slow. I am seeing that happening. It's certainly happening at our university because we're forcing it to happen. But I think in the field as a whole, it's a slow evolution. One of the things that I really tried to stress in my presentation in Hong Kong was that if you were to connect all of these subsystems within buildings, one subsystem that sits in the middle of everything and connects to just about everything are the occupants of the building. We care about indoor air quality because we care about, as you said, the building, but certainly the occupants in the building as well. And the activities of the occupants and what they do in the building and where they are in the building and how they set the thermostats and so on and so forth. I mean, the occupants themselves have a huge impact on the indoor environment and indoor air quality. And it's amazing to me that, in Indoor Air 2014 at my plenary session, there were, 800 people or something in the audience. I said, how many people got a degree in social science? Not one person out of 800 raised their hands. There's nobody in the indoor air quality community that I know of, I can't think of one, there might be one out there somewhere, who really understands people and how people interact with their surroundings, how people perceive their surroundings. Whether it be psychology or other aspects of human behavior, our community has completely dropped the ball on welcoming social scientists into our field. And I think that's a shame because I do think that human beings are at the center of almost everything in buildings. And I don't think that engineers generally or chemists or microbiologists are necessarily very good at understanding human behavior.
IAQ Radio would like to thank our association sponsors. The Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org. Particles Plus, engineers and manufacturers, feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them, wolfsense.com. IAQ marquee sponsors are John Donn Products, where restoration and abatement contractors shop. Visit them at johndonn.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Legends Environmental Insurance, the experts in insurance for environmental consultants and contractors for over 20 years at legends-enviro.com. That's legends-enviro.com.
Is it more difficult to get funding for cross-disciplinary research? Is that maybe part of the reason we don't see it as often?
Yeah, I think that's a great point, Joe. So I think historically that's definitely true, especially at the federal level, going after National Science Foundation funding and that type of thing, the big funding to do research. There's always been historically kind of a stovepipe mentality that this group will fund mechanical engineers, and this group will fund environmental engineers, and there's no reward for crossing over between the groups that have the money who don't necessarily want to share the money. I think that's starting to change, and we see that in academia, and we see that at the federal level, that there's more encouragement for cross-disciplinary collaboration and research. But I have to say that change is happening, but it's been sort of a struggle to make it happen. People are still trying to figure out how to make it happen and how to make it happen in a good way. So there are programs now at the National Science Foundation that specifically say, we want people in this field and this discipline to be working together, but it's still a relatively small fraction of research funding. So I think it's one of those things that's incumbent upon researchers to recognize that it's important and force the issue. So it's happening slowly, but it needs to happen more, in my opinion.
And I guess there are so many things that haven't really been studied adequately yet. It was funny. The other day I was taking a shower and I reused my towel, and I'm thinking about the microbiome and how often should I reuse my towel before maybe I'm getting diminishing returns. You know what I mean? And nobody's ever studied that. You know what I mean? And now that's the way in hotels now. They all want us to reuse our towel, and I have no problem with that. But for some reason, I thought about it while I was drying off. I'm thinking, I wonder how much bacteria and old, fungi and whatever else is on this towel that I'm reusing several times here. And there's some fundamental things like I have to go teach some people tomorrow. Or actually next week, how to clean a room, and whether there's been any fundamental research on whether what's the best way to clean a room that's had contamination of some type, whether it's fungal or asbestos or lead or chemical or whatever the case may be. So it's a fascinating area, and I really look forward to this. It is. I look forward to this series with you.
I'm sorry, Joe. Go ahead.
No, I just look forward to this series with you and your students and past past students, because I think we can really start to make a difference here and get practitioners asking those kind of questions and researchers helping us answer them.
Right. The microenvironments that you're mentioning, such as a room, one of the things that our students have been doing, and we've had researchers come from Europe to work with us on this in our laboratory, is we've really been studying the sleep microenvironment. When you think about where you spend your lifetime, the average American lives to be almost 79 years old, 78.7, women 81, men 76. And we'll spend over 70 years of our life inside of buildings. Over 70 of those 79 years inside buildings. And the place we spend the most time inside of buildings is lying down on our mattress. It's a third of our lives, 26 years of our lives. And it's shocking if you go to the research literature how little the sleep microenvironment's been studied from an indoor air quality standpoint. what are you exposed to when your mouth is right up against the mattress? How does your body, when it's laid out in full horizontal form, affect airflows around it? What can you do to improve the air quality in your breathing zone while you're sleeping? Are there good technologies for putting on your nightstand that'll purify the air that you can blow across your face? And in fact, there are. We've tested some of those, but the public generally doesn't hear about it. So that's kind of a really exciting area of research, and we found some really fascinating results. And I know that you're going to speak to the students about that, I think, so I'll let them talk about the results. But it's an area that I'm really excited about.
I think it's a great setup for 2 weeks. I believe 2 weeks from today we'll be talking about that with one of your students. And I mean, I'm just thinking even the difference between, what if you've got a stuffed up head and you breathe, as opposed to breathing through your nose, you breathe through your mouth? What's the exposure? What's the difference in the exposure? I mean, those are all tough questions, I think.
Yeah, and exposure to particles are, in terms of particle deposition in your respiratory system, if you breathe through your mouth when you're sleeping, you have much more particles that deposit in your respiratory system. Your nose is a great filter. Our nose hairs are a wonderful air purification device. For the kinds of particles that are emitted from mattresses.
And then you got these little
which
kids.
Is everything from bacteria to dust mite droppings to other things, yeah.
You got the little kids, the very young ones, and they oftentimes have stuffed up noses, so they're breathing through their mouth. I mean, this is all fascinating stuff. I look forward to it. All right, let me get moving. First, I got a text question. Why are there no IAQ doctors to investigate SBS symptoms?
That's a great question, and I mentioned that other countries are a little bit more proactive on these. I think, and I hope I'm not quoted wrong here, I think it's Belgium now. Belgium has, in the medical community, they have these things called the purple taxis, I think they are, or the purple cars. And what they are is, if somebody goes to the doctor and they express that they're having certain symptoms, and oftentimes it's flu-like symptoms, all the things we might associate with carbon monoxide in a building, flu-like symptoms, malaise, headaches, those kinds of things, which are also associated with sick building syndrome. There's actually a hotline for the physicians to call, and then the government has these purple cars that race out to your house, and they do carbon monoxide measurements, and they do other indoor air quality monitoring in your house. So we don't have anything like that in the United States, but at least there's one country I know of that has a direct connect between physicians and indoor air quality experts that will actually go to people's homes and see if there's a direct problem in the home that sometimes can be pretty serious. You don't want people to die from carboxyhemoglobin poisoning. So I guess the answer is, in the United States, we're a very, we're a capitalist society, and so if there's money to be made at it, then I think it'll happen. And there's money to be made when the public is educated on the issues and the public demands these types of things. And I think if the public becomes educated on all of, we could talk for hours on all the indoor air quality issues, but if the public becomes educated on the big ones, then perhaps they demand these things, and then perhaps there are companies that start up and say, let's see if we can make a business out of this.
All right.
That was a great question, by the way. I think it's a very legitimate question, and it's something that, maybe in the future we see more of that kind of thing.
Yeah, and I want to urge them to check out even next week and look back. We've had a few MDs, Dr. John Woolette, I remember, Ouellete. He used to go out and do that. He would go to his patients' homes and actually do these evaluations. And we've tried to get folks on that do that, but it is very tough to find them. I think it's a great point. All right, let's move on with what do you think as far as growing the IAQ field? What kind of fuel will ultimately help us grow this field?
I think I just mentioned one of them. I think the public needs to know more about the importance of indoor air quality. It's amazing when I do speak to the general public and I tell them how much time they spend indoors. That's a pretty simple concept, that you spend almost 90% of your time indoors, and 70 years out of your average 78.7 years you're going to spend inside of buildings. It's a simple concept, and it's amazing to me how shocked people are when they hear that. People don't realize how much time they spend indoors, and then from that point on you can sort of go down the list of all the things that they should be concerned about and ways of improving indoor air quality. And that's the other point, is we need to talk more, I think, in our field about positive things you can do to improve indoor air quality, so it's not just all negative, because the public tends to turn off to that. But I think one is education. I think the other thing, and I mean this very sincerely, this is something that I've always felt, even though I'm an academic and I'm a researcher, is that the environmental fields, if you will, that have thrived over 100 years are fields where researchers and practitioners have worked together. And I don't think nearly enough of that happens in our field. In fact, I think very little of it happens in our field. And I think that our field will thrive more when especially researchers, and I think it's more our fault than the fault of practitioners, come to grips with the fact that we need to help boil down the research we're doing in a way that practitioners can use it, and can use it on the front lines every day, that consultants and industrial hygienists and people that work with mechanical systems in buildings, they need to know about what we're doing, and they need to know what the cutting edge findings are that the research community is coming up with. And I think that connection has just not been made very well in our field, and we need to find ways of connecting research and practitioners. I don't have the answer for how that's done, but I think good people ought to come together and have a 3-day meeting or something and outline the ways that we can make that happen in the future, because it needs to happen for our field to grow. I mean, researchers can do all the research we want to do with whatever money we can scrape together to do the research, but if we're not willing to talk about it in a practical sense, it's all for naught. It's going to get published in a journal somewhere and nobody's going to read it.
Well, and
I think
I want to thank you for doing your part today even. I mean, this is what we've tried to do for 8 years now, is get researchers like yourself on to talk to the practitioners that are listening out there and work together on solving some of these issues.
Yeah, and I appreciate that. I listen to your show sometimes because I actually want to know what practitioners' needs are. And that's the other thing, is that researchers need to listen to practitioners and be told, these are the things we need answers to. I don't think we do enough of that.
Well, here's one we need answers to. It seems like, every year there's a new silver bullet coming out that is going to, fix the whole indoor environment for us with no cost or very little cost, and buy this magic machine. And for example, we have the hydroxyl machines that have been advertised, and we've got other things that come out every year. So how can we our researchers do a better job of keeping up and giving us practitioners more solid science to work with when these things come out?
So what I just said basically was that researchers don't really oftentimes know what these kinds of questions are. So you just mentioned hydroxyl radical machines, and I know that these exist, and there are companies out there that try to sell these and use these. From where I sit, I don't know how extensive that is, and I don't know, are all practitioners being faced with the possibility of using these or not? So just listening to practitioners like yourself, just saying that and saying we need information on this is important, and then researchers can actually do the research. And this kind of research, sort of simple tests on devices like that, actually doesn't cost a lot of money. So I think one is the researchers need to listen to you, and if that is one of the top 5 areas that practitioners need answers to, that's the thing that researchers need to do the research on and get the word out. I don't have any experience with those systems myself. My guess is that they probably do help disinfect surfaces to some extent for certain microorganisms, but not for all microorganisms. And then the concern becomes, if you're generating hydroxyl radicals, you're probably generating other oxidants, including the hydroxyl radicals themselves, which are going to react with the surfaces that they're placed over. And so you're going to, in part, break down those surfaces, and in part generate byproducts, chemical byproducts, which will then be released from those surfaces. And what you form is going to depend upon what you form, and how much you form is going to depend upon how intense the hydroxyl radical generation is, what else it's generating, and what the nature of the surface is that you're placing this device on. If you put this device on ceramic countertop, you're going to get a different set of reaction products than if you put it on something that's wooden, for example. But that's research that researchers can actually do easily if we're told these are the things we really need answers to. I've always felt I would love it if we could have some sort of a system where every year practitioners in this field came up with the 5 big questions that they need answers to, and then that got to the research community somehow, and that became sort of a research agenda for researchers that year, and that, maybe we could even pull some practitioners into research proposals sort of to help us, because in addition to just doing the research on something, as you know, how these things are used in the field is also important.
Yes.
And I might take one of these systems to my laboratory and I might use it in some way and get certain results that are consistent with how I used it in my laboratory, but not how people are actually using it in actual homes or schools or, office buildings. And having the practitioner involved who's involved with these things, in the field on the front lines to tell us how we should test it in the laboratory, I think is important. And we're missing those connections.
I think it's coming. IICRC, which some are familiar with, the Institute for Inspection, Cleaning, and Restoration Certification, they bought a building out in Las Vegas. They want to do that kind of research, so I need to connect you and the Richard Shaughnessy's, and I've been working on this with that group. They're the cleaners, they're the restorers, they are the people that need this information, and we need to get some practical research projects that we can do, and actually we even have some money to fund some of this, which is, I know, rare to say, and so we're going. I think we're going to see progress on this, and this is a big part of starting it, is having people like you on the show, talking with people like me, and then with our guests sending in their thoughts.
Yeah, no, I appreciate that. I think you're right on. And the other area that I find it's just getting beyond our capabilities to keep up is this kind of avalanche or sea of green products and green building materials that are just being used at an incredibly accelerated rate in buildings these days, all types of buildings, residential to commercial to institutional. And the science behind what happens to those materials over time is, for all intents and purposes, non-existent. And that scares me in some ways. We've done some testing with materials that I consider to be beautiful, bio-based green materials, that are made out of sunflower seed husk cabinetry and that type of thing. And we find that if we expose them to 80% relative humidity in a natural environment for a couple of weeks, they start looking like chia pets. They're just growing mold all over them. And we haven't even hit them with any liquid water, right? It's just, elevated RH. So I worry about these things because I don't know what we're doing now that will affect buildings over the next decade in ways that, the science just can't predict what's going to happen with some of these materials.
Yeah, and the practitioners are essentially being forced into using them because they market them so well that the building owners want them without knowing what the results are.
Right.
It's frightening.
Yeah, I agree.
It's frightening. All right, we're running low on time, so I really want to get at least one or maybe two more questions in here. Let's see. Let's go with this one. What new tools can practitioners expect in the near future for helping us with things like the microbiome and DNA analysis and all that stuff? Is there anything out there that's like ready to come out?
Well, I think that the costs of doing DNA analysis have come down so much that many more commercial laboratories are now able to do it at costs that are practical costs. So I think that is, you just mentioned that one, but because of the cost reductions, that's one area where I think there will be advancements for practitioners. I think the issue with all the DNA analysis is that generally when you take samples, you get a lot more information than you do with the culture-based analyses. And so there's a learning curve there for practitioners and again, I think this is another area where there could be connections between researchers and practitioners, is putting on some short courses and that type of thing to show how to interpret the data that you get. Otherwise, it just looks like a lot of gibberish. But there's a lot of valuable information in that. I think there's a lot more in the research community now. We see a lot of new tools that are micro tools, tools that people can actually wear so that, if somebody's complaining about something in a building, there are these, much cheaper tools now that you can hook up to people's clothing that don't cost that much, that can collect a lot of data. And so I would say sensors is another area that I think there's a revolution in right now, that over the next 5 or 6 years there'll be a lot more tools in terms of sensors for practitioners to use in buildings, whether they're left in a static position in a building or placed on a person's lapel. These will be things that don't take a week to collect the data for and send to a lab and that type of thing like we've traditionally done with exposure studies. I think the other area is that buildings now are becoming much more places where we collect a lot of data. There's just a lot of data being collected in buildings with wireless technologies now. And these wireless technologies are getting cheaper and cheaper and cheaper and cheaper and cheaper. Even, in the future, probably for doing online kind of DNA analyses, but certainly now with doing all the carbon monoxide, carbon dioxide, movement of people in buildings, GPS tracking systems in buildings, and all that kind of thing. And so in modern buildings now, there's big data being collected just in that building that we need to come to grips with and how to process. That can maybe tell stories about why certain things are happening in some zones of the building and not happening in other zones of the building. So I think these are the three things. It's probably technology, sensor technology, big data, and then the DNA kinds of work in microbiology that are going to transform the field in the next few years. And I think that information ought to become available to practitioners. And I think there is going to be a learning curve on all of it.
All right. Now, one more. Do you have another minute or two here?
I do, yeah.
Okay,
yeah.
Great. How do you suggest that these practitioners we've been talking about so much, how do they go about best positioning themselves for the future? I mean, things are changing pretty quickly. We've got more information sometimes than we know what to do with. How do we make sense of all this? How do we position ourselves?
Wow. I'm not sure I'm sitting in the best place to answer that question, not being a practitioner, but I do think that, I'm an educator, and I think that education's important, and we need to find a way of being able to educate practitioners with all the things I've been talking about, and boiling it down in a way that they can use it soon, and use it in the best possible way to use it. Researchers can do all the research in the world. Practitioners know how to get things done in the field. So somehow there needs to be a connection where research is translated to practitioners who then take that information and use it in the best way they know how to use it, not how the researchers tell them to use it, right? And that's a process that's going to require those that are members of IAQA and other practitioner associations working with those that are members of ISIAC and do research at ISIAC and other places to somehow talk to one another. I hope that in the future I can be a part of making that happen. I don't know how best to make it happen, but I really do feel it needs to happen. We tried really hard at Indoor Air 2011 to design the conference so that we would have an integration of practitioners and researchers. I think we did an okay job at that, but I think more of that is needed. I know that ISIAC now, I believe Carl Grimes is sitting on the board of directors for ISIAC, and I think that's a good thing. Need to have more of that, and maybe some of the practitioner organizations should look to researchers and ask researchers to serve on their boards and to be more active with their organizations. I think that would be a positive thing. Somehow we need to put together. I agree, though. We need almost a university. Online university or some sort of pseudo university that's translating cutting edge research information like I've been trying to talk about to practitioners, and I think we just need a nucleus of people to come together and make that happen somehow.
Maybe this is the start. We can work together and continue looking at that issue. It's a problem. It's something that we have to do something about. And by the way, I want to congratulate you on that. The Indoor Air 2011, I was there, and it was very valuable. And I thought, you maybe weren't kind enough to yourself there. You guys did a great job of reaching out to the practitioners for that particular conference. It feels like maybe that kind of the momentum stopped a little bit here, and that maybe we can get that ball rolling again.
Yeah, so the next ISIAC meeting is in Boulder next year in 2015. So Healthy Buildings 2015, there'll be two. There'll be one in the United States and one in Europe, and the one in the United States will be in Boulder, Colorado, I think around July of 2015, June or July of next year, and maybe that's a conference where we can try to make things happen again between researchers and practitioners.
I just put it on my calendar here. I'll find out the exact dates and make sure, because I think that's a great place to get started.
Yeah.
Love to meet you out there. All right, before we go, is there anything you'd like to add? And by the way, for the listeners and the sponsors that were waiting for halftime, it never came. I wanted to get these questions, and I still didn't get them all for Dr. Corsi. We'll add halftime in after the show, and I appreciate the sponsors bearing with me and letting us do that after the show. Anything you'd like to add before we go, or anything we missed?
I can't think of anything off the top of my head, Joe. I will say that I really enjoy your show. I do listen to it, and I really appreciate the fact that this is the second or third time you've had me on in 5 years. I always enjoy speaking with you, and I think the indoor air quality field is exciting because the problems are so complicated and so integrated, and that's one of the reasons that I have stayed in the field, quite honestly. It's a field that is hurting for research money. Those of us that work in this field don't get a lot of money to do research, and the fact that we stay in those of us that do stay in the field, it's because we think it's important, and it's because we think it's exciting and it's challenging and it has great intellectual merit. And what I'd like to do is to see this field advance, and as we talked about, connect the kinds of research that many of us are doing with practitioners to start using it on the front line. So I thank you for what you do. So thanks, Joe.
That's much appreciated, and we definitely appreciate having you on the show again, and look forward to a little series of shows where we can start to build on what we started here today. All right, this is Radio Joe Hughes saying thanks so much. Dr. Corsi?
Thank you, Joe.
Thank you. We really appreciate having you. And next week, we've got Rebecca Morley, the Executive Director of the National Center for Healthy Housing. I'm still working on a second guest because we're going to talk about their new standard for healthy homes, the Healthy Home Standard, and we're going to get one of the more technical people that were on the committee there to join us with Rebecca Morley, so we're looking forward to that. In 2 weeks, we'll have Dr. Corsi and one of his students back. We're going to talk a little bit about that exposure issue and, how much exposure we have when we're in a mattress. Now we're talking, 1/3 of our lives is spent there. So amazing that we don't have more information on that. It's coming. I want to thank also the Z-Man wasn't here this week. He'll be back next Friday at noon. Of course, we'll get him back on and get back in the seat here next week. Also, thank you to our sponsors for sticking with us and for letting me go through without the halftime break today. Most importantly, thanks to our growing group of loyal listeners. And thanks, guys, for sending in these texts. We're going to take that text or two that had some recommendations for guests and some great resources for people that are interested in Dr. Corsi's work. We'll post those on our website, and I'll get in touch with the guest recommendation. Thanks for joining us. Please come back next Friday at noon for the next episode of IAQ Radio.
For IAQ Radio, I'm Spike Reel saying thanks for listening.